Hi, I'm Ryan Reyes. You've seen me in such fine quality epic chemistry educational videos such as Chemical Formulas Part 1 and Polyatomic Ions? What's up with that? Part 4. Okay, so in Part 1 you got to balance a binary ionic compound like Na and Cl. And you learned those techniques. Now, as some dude on some TV show long ago said, let's kick it up a notch. What if we got something a little bit different? What if we got something like chlorate and nitrate and benzoate? Ooh, they sound like big little hunking molecules. In a sense, they are. They are composed of more than one kind of atom out there. Chlorate is a -1, that's a ClO3. Nitrate is NO3 with a -1 charge. And benzoate, that's a big one, C7H6O2 with a -2 charge. Now remember, those charges tell us it picked up electrons. Each electron is -1. Now the fact is, these guys are not balanced, which means they're going to look for something positive to hook up with. The whole goal about balancing any chemical formula is to reach zero balance, okay? That means if it's zero, then the compound is stable. If the compound is stable, it is not likely to react. Now, that doesn't mean we can't make it react, because we can. O2, for example, is stable, and it won't do anything. But if you light a match right next to the O2, it's going to burn. You're making it do something by itself. But so here, what we're going to do, we're going to go ahead and I'm going to work through a few of these with you guys here so that you guys get to see what that looks like. So let's go with calcium chlorate. Now calcium, you guys already know it's a 2+. Chlorate is ClO3 with a -1 charge to it. Now, here's the thing. What part goes in front of the formula? Most of the time, it is going to be your cation. That's right, the cation. Okay? That's how you positively remember it, right? So with that, we have our calcium and we have our chlorate. This is not an I, this is a letter O for the chloride ion. Okay, and now we're going to do the Crisscross Method. Now, in the last video, you saw that. Now, of course, if you didn't see the last video, I would suggest you check out Part 1. Okay, because that's going to get you guys set up for this. All right, let's keep going. So, in the last video, I showed you guys a time-honored technique called the Crisscross Method, where we have our cation, our anion, we have our charges. And what we're going to do, we're going to figure out how many calciums and how many of these ClO3s we're going to have. So we're going to do this. We're going to go ahead and we're going to bring the two down to here. And we're going to bring the -1, which we're going to make that absolute value because it's a 1. We're not bringing down charges, guys. We're bringing down the number of the item in question. So we're going to go ahead and we're going to bring that down to here. So that's what it's going to look like. A Ca1 ClO3 2. Except, here's the problem. How are we going to represent this? So we know the one goes away. You learned that in the last video. Now, what do we do with the ClO3? You got 2 of them. Now, some people might be thinking, oh, I could do this. And I got Ca2ClO3. No, that's not going to work. Some people are going to think you mean there's 2 calciums in there, which is not true. Other people are going to say, well, yeah, you got 2 of those ClO3s, I guess. But that won't make any sense. And you're never going to see a chemical formula that's going to have something like this where a big number is in the middle of a formula. No, 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 no. So what do we do? Well, that's one way to do it. That was the wrong way to do it. Let me show you another wrong way to do it, okay? Where I have CaClO3, 2. Now this is another wrong way to do it. And you're sitting there going, well, wait, aren't you saying that there's 2 of these? No, you're saying there's 32 oxygens. See, and that's the problem. So now, how do we fix that? Well, there is a time-honored technique that is used in English and in math, and sometimes maybe in your text messages. I don't know, I don't read your text messages. That's just downright creepy. Okay, so we're going to go ahead and we're going to use parentheses like this. And you'd say, wow, it's like math, right? Do we sit there and multiply all these out? No, 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 no. You don't need to multiply it out. All we're saying is, look, whatever's inside of these parentheses, we have 2 of them. Oh, but wait. So if you did this, could we do this? Wouldn't it be the same as this? No, no, it's not the same. No, 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 no. No, 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 no. Yes, the parentheses. Yes, 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 yes. This is the right way to do it. Now, how do I check for charges? I've got 2 here. I've got a +2 here with my chlorine, my calcium, and I have 2 times a -1. So that gives me a +2 and a -2. They add up to 0. This is a balanced formula. All right, let's move on to the next one. So we have sodium chlorate. Okay, so here's sodium with a +1 and the ClO3 with a -1. We can do the crisscross method again. Now remember, in the crisscross method, you don't have to write the 1. We assume it's going to be there. So NaClO3. Wait, you're forgetting something. Canu, aren't you supposed to do this? No. No, 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 no. No, 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 you don't need to do this because we only need 1 of these. So, NaClO3, this is the correct answer. Na gives us our +1, the ClO3 is a -1. They balance. Okay, so this is the correct thing for sodium chlorate. All right, let's move on to another one. Aluminum chlorate. All right. Well, we have an Al with a 3+, again, ClO3 with a 1-. So we're going to go ahead and do crisscross. Okay, so Al, and we only need 1 of those, so we don't have to write the 1. We have ClO3. Now we're going to need 3 of them, so that means we're going to use our parentheses like this. Now some people might be thinking, well, wait. Couldn't you put the 3 up here? No, no. Winning? No, 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 no. Bad, 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 bad. Okay, wrong. The way to do it is AlClO3. Since I have 3 of them, I put 3 here. That's the correct way to write it. And again, Al has a +3 charge. I have 3 times -1 is a -3, so these cancel out. So this is what we have, ladies and gentlemen. Okay, let's see, do I want to do another one? Let me see. Silver chlorate, there we go. Let that be our last one. So we have Ag with a +1, and we have our chlorate, ClO3 with a -1. Oh, come on, you should be able to do this one. Crisscross, 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 crisscross. Do I need to put a parentheses here? No, I only have 1 of these. No parentheses needed. Do I need to put a 1 anywhere here? No, you don't. Because if it's already written, we're assuming that you have one of these. So that means we have a silver with the chlorine attached to the silver, and 3 oxygens are hooked up to the chlorine. That's it. That's it for the formulas, guys. So I hope this benefited you guys. And hey, I'm Ryan Reyes, and 7th period knows me. You take it easy.